Look at your hand for a second. No, really, just pause and look at it. Move your fingers a little. Press your thumb against your palm. Feel that pressure, that resistance. It feels solid, obvious, like there's something there. Now here's the part that doesn't sit right. That hand you're looking at? It's almost entirely empty space. Not kind of empty. Not philosophically empty. I mean, if you zoom in deep enough, past what your eyes can see, past what even most microscopes can show, there's almost nothing there. And I know what your brain is doing right now. It's saying, okay, sounds interesting, but also sounds fake. Fair. So instead of asking you to believe it, let's walk through it slowly. No rush. No big words unless we really need them. Just you and me, figuring this out step by step. And if at any point your brain goes, wait, what? That's a good sign. Also, before we go deeper, if you like this kind of thinking where we take one idea and really sit with it, hit subscribe. This channel isn't about fast facts. It's about understanding things in a way that kind of sticks with you, even after the video ends. So let's start with something basic. What does solid actually mean to you? It probably means you can't pass through it. It resists you. You can sit on it, stand on it, hold it. Like this table, or your phone, or your own body. There's a kind of certainty to it. You don't question it. No one wakes up and says, is my chair actually solid today? That would be weird. But physics doesn't really care about what feels obvious. It asks a different question. What is this thing made of? And once you go there, things start to shift a bit. Take anything around you. Let's say your phone. You can break it down into materials: metal, glass, plastic. Break those down further, you get molecules. Break molecules down, you get atoms. And for a long time, people thought atoms were like tiny solid balls, like little Lego blocks of reality. That would have been nice. Simple. But that's not what we found. Not even close. An atom has a center, a nucleus. That's where almost all the mass is. Protons and neutrons packed tightly together. And then there are electrons. But electrons don't orbit like planets. That picture you saw in school? It's not really right. They exist in this fuzzy region around the nucleus, like a cloud. You can't point to a precise spot and say it's right there. It's more like a probability. Now here's the strange part. The size of that nucleus compared to the whole atom is insanely small. I'll try to give you a picture. If the atom was the size of a football stadium, the nucleus would be like a grain of rice sitting at the center. Everything else, the entire stadium, empty. Just space. Take a second with that. Don't rush past it. Every atom in your body is like that. Mostly empty. And your body is made of, I don't even know, trillions upon trillions of these atoms. So what are you, really? A giant structure, built out of almost nothing. That sounds dramatic, but it's actually just accurate. At this point, your brain should be pushing back. Something like, okay, but I feel solid. I can knock on a table. I don't fall through the floor. Exactly. So what's going on? If everything is mostly empty, why doesn't everything just pass through everything else? Why don't your hands just slide through each other? The answer is forces, not stuff. Not solid chunks colliding. Forces. Specifically, something called electromagnetic force. The electrons in your hand and the electrons in the table, they repel each other strongly. So when you press your hand on a table, what's really happening is these invisible forces are pushing back against each other. You never actually touch the table in the way you imagine. There's always a tiny gap, a gap filled with force. It's like trying to push two magnets together on the same side. They resist, not because they're solid, but because of the force between them. That's your everyday reality, just scaled up so you don't notice. Yeah, that sounds extreme, but think about it. Every time you touch something, you're feeling resistance from electromagnetic interactions, not actual contact. Not atoms smashing into each other like billiard balls, just fields pushing. Your entire physical life, walking, sitting, holding things, is based on this. It's kind of wild when you say it out loud. Now you might ask, okay, if it's empty, what's actually there? Is it just nothing? Not really. That space is where the electrons exist as probabilities. It's where these invisible fields are present. Modern physics, especially ideas pushed by people like Leonard Susskind, suggest that what we call particles are actually little excitations in underlying fields. So the universe isn't made of tiny hard balls. It's more like a set of fields, and particles are just ripples in those fields. Even the empty, parts are still part of that structure. So empty doesn't mean nothing. It just means not solid matter. Let's do something a bit uncomfortable. Imagine you could remove all the empty space from your body, not change anything else. Just squeeze out the emptiness. What would happen? All the nuclei would be pushed together, tightly, and your entire body would collapse into something incredibly small, like microscopic, smaller than a grain of sand. But here's the disturbing part. Your mass would stay the same, so you'd be unbelievably dense, like something you'd find in a neutron star. That's how much empty space you're carrying around right now. The reason this feels wrong is because your brain was never built to understand this. You didn't evolve to think about atoms. You evolved to survive. So your brain gives you a useful story. Things are solid. Space is empty. Objects touch. That story works. It keeps you alive. But it's not the deeper truth. And physics kind of ignores what feels right. It just follows what's actually there, even if it sounds ridiculous at first. So if your body isn't solid in the way you thought, what are you? You're not a block of matter. You're more like a structure, a pattern, a stable arrangement of atoms, which are mostly empty, held together by forces. There's no solid core hiding somewhere inside you. No tiny hard version of you. Just layers of structure and interactions. That's it. This idea doesn't usually hit all at once. It kind of creeps in. You start seeing things a bit differently. Like, when you hold something, you remember, I'm not actually touching this. Or when you look at your hand, there's this moment where you think, this is mostly space, and yet here it is. It doesn't make things less real. If anything, it makes them more interesting, more fragile in a way, more precise. Now look around again. Nothing changed. Your room is still your room. Your body still feels the same. You can still pick things up, walk around, sit down. Reality didn't break. But your understanding shifted a little. You're seeing through the surface now. Just a bit. It's strange, honestly. The deeper we look, the less the universe matches our intuition. Solid things aren't really solid. Empty space isn't really empty. And you're not this fixed, rigid object moving through the world. You're more like a pattern held together by invisible forces floating in vast emptiness that somehow feels like a person. And yeah, that sounds a little poetic, but it's not poetry. It's physics. If this made you pause, even for a second, that's enough. Subscribe to Physics Unrushed if you want more of this kind of thinking. No rush, no noise, just ideas that stay with you. Because the truth is, what you see is only the surface. And underneath it, things get very, very strange.